1, 2, 1, 2. Yes, hello everyone. So everything is solved. Thank you for bearing with us. We had a few technical hiccups, but it's all working now, and I get a nice remote as a bonus, so it's cool. And so I know it's the end of the morning, and there's already a lot of content that has been displayed, a lot of things to learn. There's a lot of content in this presentation as well. It's a 20-minute speed run of everything that's new in Apollo Kotlin 3. So please bear with me, and then we can all have lunch together. A small refresher about what's Apollo Kotlin. So it's a type-safe, caching-enabled GraphQL client. It's a lot of words to say. It's something that takes GraphQL queries on one side, a GraphQL schema on the other side, does a bunch of processing, and generates models for you. And these models are all type-safe. It also generates parsers using codegen so that you don't have to use any reflection or anything to use these models. So you have the warm, fuzzy feeling that if you can access a property in your Kotlin code, it has been correctly queried in your GraphQL query, and it's the expected type. The project is on GitHub. It's all open source. It used to be named Apollo Android. It's now Apollo Kotlin because version 3 is a huge release. It has a lot of major changes, and this is what I'm going to talk about today. This presentation is in 3 parts. The first one will be about the really big blocks, like the foundation work that we need to do on the low-level APIs to make this major version happen. Second part is about all the nice-to-have and all the quality of life improvements that we were able to ship in thanks to this foundational work. And in the last part, I will talk about what's new and what's coming in Apollo Kotlin. But let's start with the big block. And the first one, obviously, is Kotlin. So if you were to take the project 1 year ago, you would have seen half of this bar in that yellow-orange Java that I don't like too much. And now it's all purple, or the nice Kotlin purple. So that means if you've been following the project, you know in Apollo Kotlin 2, you still had the option to use a Kotlin runtime. But you also had a JVM runtime. So you had to choose between these two runtimes. On one hand, you had a JVM Android runtime using callbacks written, for the most part, in Java. And then you could slap extension to use coroutines on top of it. And you had all the features there, like you had caching, you had auto-persisted queries, you had query batching, everything. Like it's a full set of features. If you wanted Kotlin-friendly APIs and something that works in multi-platform, you could opt in this other runtime named Apollo Runtime Kotlin. And then you had something written in Kotlin that works for all the platforms supported in Kotlin, but doesn't have all the features. So it was a trade-off, like which one to choose. So version 3, and this is the biggest change there, unifies all of this. Now you can depend on Apollo runtime, and you get everything multi-platform and all the features, which is quite nice. So that means you can do a GraphQL query as you would call a simple suspend function. This is the first line here. If you want to do a mutation, so a mutation is the equivalent of a post in GraphQL world, you would, same thing, just call a suspend function. And if you want to do more advanced stuff like watching your normalized cache or listening to events from your server, you can expose subscriptions as flows, and then you can collect them in your context of choice, dispatcher of choice, whatever, like we all love coroutines. So this is a very quick introduction to all the Kotlin multi-platform that was required for this big version. Obviously, there's a lot going on under the hood, which I'm not going to go into the details right now. If you want to learn more about it, we have a talk together with Tasso that was presenting earlier today, and Ivan we gave at Kotliners, and it's about all the very gore details of the migration. One thing to note, though, is that Android and iOS are pretty like feature complete. You have almost everything on both platforms, with the addition that Android has this HTTP cache, but that I'm not recommending too much because the normalized cache is much better, but we can discuss that if you want. JavaScript is just missing the SQLite cache, so persistence in JavaScript. I don't know, maybe that's a thing. And Linux and Windows, actually, because Kotlin also supports Windows, is lagging a bit. I would say it's mainly because of lack of interest. So if you have interest in Linux or Windows support, please reach out. And I think we can get it working quite easily. I mean, nothing is easy in software, but it should be doable. So that's it for multi-platform. Second thing I want to talk about is codegen. So codegen is a core value proposition of Apollo Kotlin. It's what makes everything type-safe and what makes everything safe at compile time. So here on the left is a standard GraphQL query. I mean, not so standard because it uses fragments. So fragments in the GraphQL world, and again, it's not a talk about GraphQL, but fragments, this is how you would do stuff like polymorphism with interfaces and classes. This is how you would also create reusable classes so that you can group fields together. So this query on the left, it uses two kinds of fragments. It's querying a hero from the Star Wars API. The Star Wars API is a simple API, GraphQL API. You can find it online. And it returns either a droid hero, if your hero is a droid, or a human, if it's a human, like Luke Skywalker, or maybe Princess Leia, or someone else. It uses an inline fragment for droids and a named fragment for humans. And you would typically use it like this. So you type hero.asDroid.primary function to get something on a droid, and hero.fragments.humandetails.height for humans. Well, that's a mouthful. Especially if you look at the JSON response, like what you're getting back from the server. There's nothing named asDroid or fragments or human details or anything like this. You would just get like a flat JSON. If you have a droid, you have the primary function, and then if you have a human, you have the height. It's just there with the other properties. So the idea behind the codegen in version 3 is, instead of have all these intermediate wrappers, why not leveraging all the Kotlin sealed interfaces, all the exhaustive when statements, and use type inference to the best of it, and depending the context of your object, directly access the fields like you would do when you read the JSON. So this is what's happening here on the right. I guess you've guessed at this point, but purple is GraphQL. Blue is Kotlin, which is not the same thing as the GitHub bar. I should work on that. Anyways, on the right, you have access directly to the properties like you have them in the JSON. So there's no more asDroid, no more human fragment, nothing like this. So in that way, the 3.x codegen, we call it response-based because it maps 1-1 with the JSON response. And it's all working. To model that, using Kotlin, we had to make a few changes. For an example, the fragments, which are, remember, something to handle polymorphism and grouping fields together, we modeled them as interfaces because obviously you want to store the field only once. There is only one field in a JSON. So here we have a fragment for the human details. We also have a sealed interfaces for the base type of every object. So here we have a sealed interface for hero. Yeah, all the heroes have a name, but then different kinds of heroes have different properties. And then this three last line at the end, you have all the different possible implementations. So we have droid hero, human hero, and the fallback hero, which is, it's an interesting one. You wouldn't theoretically need it, but remember we do everything at build time, and there's no guarantee that the server will not evolve. So if you ship your app and someone in the backend decides to add a new hero type, maybe it's an alien, maybe it's something else, this is going to be mapped to other heroes, so you can still read the name accordingly. And it's working well. It's really good. You have the full GraphQL type system. You can use polymorphism. You can use all of that. So we were pretty happy about it, and we shipped it in a developer preview last year. And we got a couple of weeks later this issue. So someone managed to write a 100 lines GraphQL query that in turn generated something like 10K lines of Kotlin, and in turns that generated a DEX class that is more than 64K bytes and kilobytes, sorry. And the Android virtual machine just cannot deal with this. By the way, small note, if you want to know more about DEX, there's a very nice talk later today at 5 p.m. about the DEX file format, which I'm definitely going to attend to learn more about this. But anyways, if we want to understand really what's going on there, and I'm going to do a little bit of graph theory, but not too much. It's actually tree theory. I'm going to get the ancestors of Luke Skywalker. So if you want to get the parents of Luke Skywalker, you can do so with fragments in GraphQL. You would create a fragment, and this fragment would get the name of the mom and the dad of Luke Skywalker. You use this in your query, and you get, well, a JSON with the parents of Luke Skywalker, which, if I'm not mistaken, are Padme and Anakin. You can do the same thing with the grandparents. You would add a new fragment, and this fragment, you inline it in the parents. So you end up with the 4 grandparents of Luke Skywalker, which I don't know their name. I'm really sorry. I'm not so good in the Star Wars lore. Same thing, if you want the great-grandparents, you add a new fragment. You use this fragment inside the grandparents, and you end up with the 8 grandparents. I think at this point, you're seeing where I want to take you. You can do this at the level 4. You get the level 4 ancestors. You add 1 fragment. You get 16 ancestors. You can continue like this a long time, and you get a perfectly valid exponential function. So this explains why the codegen we had could, in some cases, where you have a lot of nested fragments, so here we have 6 levels of nested fragments, could generate a lot of Kotlin, because we need Kotlin for each and every leaf property here. So it's going to grow proportionally to the size of the response. If you take a step back, this is very cool for the language, for the GraphQL language itself. It means it's very expressive. You can express in a few lines, you can query a lot of data. So it's a nice feature to have, but maybe not always when you want to do codegen. So we went back a little bit and were, okay, this is cool. We have all the type information. This is really nice, but in some cases, this will just not work because it's too much codegen, it's too much code. So instead of generating models based on the JSON response, we went back and we said, hey, if the GraphQL language is so expressive, we could use that in Kotlin as well and model our data classes after the GraphQL operation. So an operation, it's just a GraphQL word to say either a query, a mutation, or a subscription. So it's a generic word. And then you would use it like this. And turns out this is working too, and it's more manageable. You don't get all the type information, but you can still access all the fields you want. So in the end, we ended up with trade-off. Like every software engineer would say, the solution to every problem is it depends. So we decided to go by default with the operation-based codegen because it's not going to blow up your JVM or your art runtime or whatever. The operation-based codegen, it maps to the GraphQL operation. It doesn't have all the type information, but you're guaranteed that it will not break your compilation. Once you're familiar with this, you can move to the response-based codegen, and there you can do a lot of cool stuff like casting and use sealed interfaces, exhaustive when statements, and everything. You can see a small yellow line here, a yellow dot, which relates to performance, which takes me to the last point in these big blocks. We've seen Kotlin Multiplatform, we've seen new codegen options, and really the last focus of this big version was performance. In version 2, we used to do something like this. So you had a network JSON, so bytes you get from the network. We would get all of that and put it inside a big map. So we allocate the size for the full response and put it in a dictionary. And then from that dictionary, we would start parsing and generate the data classes. Well, in version 3, this intermediate step is done, which means not only you save on memory because you don't allocate this intermediate step, but you also basically have the parsing for free because it happens during the network I/O. As you receive bytes, the models are created and parsed, which means whenever you receive the last bytes in your response, you will have your model ready to be consumed. So if you remember this small yellow dot there, it's a small caveat. If you're using something operation-based codegen, you can have what GraphQL calls merge fields. That is a field that appears at different places in your GraphQL query. In that case, we need to rewind the stream, and then we need to buffer it, so we are back to the big map thing. The good thing is we only do it for the subtrees that are actually required to be buffered. So on average, it will stream most of the query you're using. Another big performance improvement is if you're using the SQLite normalized cache. This is also known as the N+1 problem if you have been doing backend development before. This is a classical problem with GraphQL. Is you're doing a query like this, it returns an array of objects. Version 2 would just make one SQLite query for each and every object, and this is slow, like super slow. So in version 3, we have this SQLite batching where we do all the list and we generalize that to object and stuff like this. We collect the reference as we go down the responses and we batch as much as we can. And we have benchmarks that show it's at least 3 times faster and it might be even more in your use case. So that's it for the big blocks, and I know that's a lot. Kotlin, codegen options, and performance. These were the 3 focus. For the smaller stones, the smaller nice-to-have improvements, we have now what we call an AST library. So you can use Apollo AST, and you can parse every GraphQL document and have Kotlin classes and Kotlin structures that allows you to read and write this document. If you're not familiar with parsers and everything, I strongly recommend you read the GraphQL spec. I know reading spec is not what you would recommend to your friends, but trust me. This one is pretty cool. It's nicely written, and GraphQL isn't a super complicated language. You can see a lot of the constructs there, and you can access them using Apollo AST and use them in Kotlin, which means you can do stuff like this. If you have a query on the left, you can get the name of the query. So that's not super useful. But you can think of use cases like this, where you introduce your own client directives that defines that some fields in your queries are only available in some context. Here, for an example, you might be talking to several versions of the server. And depending if you're talking about version 3, with version 3 or version 2, you can decide to change the GraphQL document at runtime. So you can edit your document and just trim the field that's not supported if the server does not support this. Talking about client directive, something, if you've been following me, you know I love GraphQL. You also know there's one thing I don't love about GraphQL is that everything is nullable by default, and it's a pain in Kotlin. If the backend developer forgets to add the exclamation mark, you end up with a lot of safe calls everywhere. That's not cool. So we introduced the @non-null client directive. How does that work? It allows you to turn any nullable GraphQL field into a non-null GraphQL property. So if your schema defines the users with an email, this email, like there's no exclamation point, you can use the @non-null directive in your operation and make sure this is handled during parsing and you don't have to handle this yourself. You can even do this at the schema level by adding an extra.graphqls file next to your backend schema. So this is client extensions to your schema. So you can basically take your schema from your backend and modify the fields and modify their properties. And if you do this, all the emails in all your queries will be non-nullable. Another cool client directive, and we've heard a lot of feedback using version 2 about how the cache resolvers API were a bit advanced and sometimes not easy to grasp, like there's a lot to ingest when you first look at them. You can now configure your normalized cache using client directive, so it's all declarative. You do this using the type policy client directive, and the nice thing with this is you defined which fields in your objects are the key fields, and the compiler will make sure they are embedded in all your queries. So you don't have to remember to include them. They will be included by default during your compilation. I think that's it. There's a mock server, but I don't want to talk. I don't have time. I want to talk about it, but I want to keep a few minutes of this presentation to talk about the upcoming thing, and also the elephant in the room. And for once, the elephant is not Gradle, it's Java. Because we have all these nice coroutines APIs, and because we use Kotlin everywhere, like we have extension functions and everything. And it's not really nice to use in Java. Like if you're a Java developer, you will find it a bit awkward. So we have plans to introduce a new Java runtime that is parallel to the Kotlin one, and that will not have the Kotlinix coroutines dependency. So if you're a Java developer, follow this issue, and we're hoping to get something done there. And there's a lot more stuff we're working on, pagination APIs, which is the current focus. We want to improve the test builders, new memory models, schema transform more. And I will conclude with this. Also, your features, like this is all open source, this is community driven. So if you have something, a pain point, a new use case, please reach out. Either on GitHub, we are also active on the Kotlin Long Slack and on Twitter. And we can work together to make things happen. So that's it for me. Thank you for bearing with me. And that's it, I think. Thank you.